All right, so this is section 2.2, and it's the second exploration and practice that we've done with these concepts. So we're looking at some proportions, we're looking at some percentage questions, translating between them, and also being able to solve some things. So this first problem, we have a proportion, which says 36 over 45 equals x over 100, and it asks the question, 36 is what percent of 45? So I just want to remind you, so they're giving you an example there. I just want to remind you of a couple things here, which is the number that comes after of, that has to be in the denominator. So you see, oh, that of 45, that 45 has to be in the denominator. Then 36 is this part right here, right? 36 of 45 is, and then this is the what percent. Remember that the percent is always half of your proportion, and in this case, since it's what percent, we're looking for the percent, and so we make that our variable x over 100. So let's apply that to A. I'm just going to type here because I think that will be easier. So when I see 180 over 100, I'm thinking 180%. Then when I see n, I'm thinking what number? When I see equals, I'm thinking is. So 180% is what number of 36? Probably a more common way to write it would be, what number is 180% of 36? So sometimes I like to write it, this right here that I'm highlighting would be exactly what I see. 180% is what number of 36? But we like to write it as what number is 180% of 36? So that is what I would suggest for A. Okay, now, if you haven't done this already, I would really suggest pausing the video and trying B, because then that gives you a chance to see if you can do it on your own. Okay, so hopefully you paused it, you wrote something down. So something I am noticing is the A over 100, and that is what percent, right? Because we don't know what percent it is. It's not 20%, it's not 60%, it's what percent. So I'm going to write down what percent. Then I'm going to write is, because that's the equal sign. And then I'm going to write 27 of 4. Okay, so that's one way to write it, but usually what we would probably say is 27 is what percent of 4. That's just probably a more common way to write it. And so that's how we'll write it, but it's the same thing, right? 27 is what percent of 4? Okay, now you can try C on your own, hopefully. But C, let's see here. We've got the 386. We've got a variable down in the denominator, which means we're going to need to have the phrase of what number. And then we have 712 over 100, which is 712%. So what I would write is 386 is 712% of what number? You may have written 386 of what number is 712%, and that's okay, but this is probably a little bit clearer. Okay, finally for D. Okay, again, try this on your own. Pause the video, then see if you can write down your thing, then come back to it. Again, active studying is much better. So trying to force your mind to remember some of those things and think about those things is going to be ultimately more beneficial for you than just following along. So try that, then follow along. So I'm going to write 11 of 111, right? 11 of 111 is what percent? Probably a more common way to write it would be 11 is what percent of 111? So that is probably how I would write it. You can see that the number that's in the denominator is after the of, and I've got this what percent over here. Okay, so that's number one, just converting between these proportions to percentage questions. Okay, all right, let's let's move on to the next one right here. Oh, whoops, I annotated here instead of actually writing on the board. So I'm gonna have to clear this off, but that's okay. Now we'll go to number 2, and this time I'll actually write on here. So write each question as a proportion. I guess I'm going to add a text box. And find the unknown number. Okay, so remember that for the proportions, one side should be the percentage, and the other side should be a combination of other numbers. So when I see 75%, I'm going to just start right off by saying that's 75 over 100. Maybe it would be a little bit better to actually not do the text box, but rather to actually draw. So let's draw, see if I can get this to go. Okay, so 75% would be 75 over 100 is 75%, okay, and then is, okay, this is a confusing thing, what number of 68? So that would be x over 68. So we have to be careful because we have to make sure that the percentage is all on one side. And so then it says, find the unknown number. So what I would do is say, well, what has been done to x? Well, x is being divided by 68. So to undo that, what I can do is multiply by 68. Okay, and sometimes I like to write 68 over 1. And this divides, and I should just get x is equal to 75 times 68, all divided by 100. And I don't have a calculator on me, but you'll be able to find that. Okay, now you should try B, but pause and then try B. And then check your answer. So hopefully you paused, you thought about this. 120%, boom, 120%, it's got to be 120 over 100. Now it's tempting to put that over 37, but that is not what we want to do yet, because we have to make sure that that one side of the proportion is just the percentage. So 120% of 37 is what number? That's very similar to this. It should be x over 37. What number of 37 is 120%? And so what I would do now is multiply both sides by 37 over 1. And that will allow me to then find that x is equal to, and you're going to have to simplify this, but 37 times 120 divided by 100, which is some number you're going to find. Okay, C, I'm going to let you pause, hopefully, and try it. But 270 is what percent of 90? Okay, so of 90, I got to have of 90. It's got to be in the denominator. 270 goes in the numerator, and is, and then it should be what percent, and what percent should be a variable over 100. Okay, I'm pretty sure what we could do here, we could actually simplify by dividing by 10. So then we'd have 27 over 9 is equal to x over 100. 27 over 9 is actually just 3. So we'd get 3 equals x over 100. Then we could multiply both sides by 100 and get 300 equals x. So 300% is the percent that we would need. Okay. For D, what percent? That's going to be x over 100 is, what percent of 18 is 0.2? So that should be 0.2 over 18, and then you can solve it from there. So hopefully that helps a little bit. Just remember that the things that come after of need to be in the denominator, and one side should be the percentages, right? And that can at least help you when you're translating from percentage questions to proportions. Okay. So moving on to number 3, Diana had a large stack of playing cards. She knew that 17 of them were kings. Okay, one thing that's pretty good, a good strategy, I would say, for solving proportions is to or solving any word problem is to write things down that you knew. Okay, so basically we've got lots of playing cards, lots of cards. And by the way, 17 are kings. Okay, that's great. She took a sample of 30 cards. Okay, sampled 30 cards. And 4 of those were kings. 4 are kings. Interesting. Approximately how many playing cards did Diana have? Okay, so this right here is our X because that's what we're looking for. Lots of cards, but how many? So anytime you want to find something, that's what we use the variable for. So now we can set up our proportion. It should be something over something equals something over something. So your unit should match. So we could maybe say 17 kings out of total number of cards has to be equal to 4 kings out of the 30 cards. So we've got 17 over x equals 4 over 30. And now, why don't we use the cross products property, which says we can multiply these two right here, and we can multiply these two right here, and we still have an equation that's true. So if I multiply 4 by x, I get 4 times x. If I multiply 30 by 17, well, let's see here, 30, 51, I think that's going to be 510. Does that sound right? Let's hope so. So then I should get x is equal to, since I'm multiplying by 4, I can divide both sides by 4 and get x is equal to 510 divided by 4. Now, 510 divided by 2 is 260, 255. So that's going to be 255 divided by 2. Okay, I must have done something wrong here because let's see here. I should not come up with a non-whole number. So let's see here. 17 over x equals 4 over 30. Okay. So 4x is equal to, so 3 times, that would be 30, and 3 times 7 is 21, 30, 40, 51. Oh, approximately. That's the key word, approximately. So this is, we're going to approximate. So 255 divided by 2 is, let's see here, 127.5. So I'm going to say about 128 cards, right? Because this is an estimation thing. It's not going to be exact, but we know that there are about 128 cards. Okay, the last one here is number 4, write and solve a proportion for each situation. So remember, unit here, unit here, unit here, unit here, all those units have to match. Candy maker put prizes in 600 bags of candy. All right. A, 600 bags. He then took a random sample of 125 bags, 125 bags, and counted 8 bags with prizes, 8 bags. Okay, 8 bags with prizes. Approximately how many bags of candy did the candy maker have? Oh, this one has prizes too. Okay, so let's make sure our units match. So total number, that's what we want. Okay, how many? Then 600 out of the total, 600 had prizes. Then out of 125 bags, 8 had prizes. So our proportion should then be x over 600 is equal to 125 over 8. Okay, again, I suggest using the cross products property, which says you can multiply these two and multiply these two. So I think that might be a good idea. So if we do that, we will get 8 times x is equal to 125 times 600. Okay, so then x should be 125 times 600 divided by 8. Let's see if I can do this in my head. Well, 600 divided by 2 is 300. Divided by 2 again is 150. Divided by 2 again is 75. Divided by 2 again is, woof. Well, 75 divided by 2 is 37.5. So I think it's going to be that. And then I could find an approximation there. But again, I don't have a calculator, so I'm not totally sure. Okay. For the second one, it says a candy maker estimated that she had 2,500 bags of candy, of which she put 92 prizes in 92 of them. She collected a sample in which there were 7 bags of candy with prizes. Approximately how many bags of candy were in the sample? Okay, so we'd want to set up a proportion and say, well, there's 92 with prizes out of the 2,500. Then approximately how many bags of candy were in the sample? Okay, so then 7 with prizes out of how many total? So that would be your proportion for B. This up here is prizes, and this is the total, and this is the total. So that would set that up correctly and have your units match. So hopefully you're getting some work done here and it's making some sense. And hopefully this video is helpful. All right. That's it for now.